Alright, let's get started with chapter 3. We'll start with section 3.1, and this whole chapter is about functions, and so 3.1 will be kind of just introducing some basic ideas about functions. So, objective 1, determine whether a relation represents a function. So, a relation is a correspondence between two sets. So, typically we're going to be doing between x and y. Those will be our two sets, and so the relation is the correspondence, the relationship between them. If x and y are two elements in these sets, and if a relationship exists between x and y, then we say x corresponds to y, or that y depends on x. Okay, so that's important. Y is going to be your dependent variable, x is your independent variable, x relates to y. You write the arrow going towards y, you input x, and you output y. Okay, so let's take a look at this. Maps in ordered pairs. So, if you have a list of all the states, or at least some of them, and the number of representatives that they get, Alaska gets 7 representatives, but so does Colorado. Arizona gets 8, North Dakota 1, Florida 25, California, big state, gets 53. So we're just relating each state to how many representatives it gets. Okay, but keep in mind this Colorado and Alaska situation where two different inputs are resulting in a single output. That'll be important here shortly. Okay, so there's a list of all the options. Now here's another option. So now, before we had multiple inputs, so we had the Alaska and Colorado going to a single output. Here we have a single input, 1342, resulting in multiple outputs. And then this option, it's just a straight 1-to-1. Dog 11, duck 10, rabbit 7. Okay, so how does all that work out? If x and y are non-empty sets, meaning there's stuff in the sets, a function from x to y is a relation that every x has only one y. Alright, so this is a function because every single x in here goes to one specific y value. Now it's okay if different x's go to a single y. That's fine. Alright? It's just you can't have this situation where a single x results in two different outputs. Not allowed. Alright? So determine whether a relation represents a function. This would be a function because every single input results in a single output. Alright, so with that information, try problem 15. Alright, how about this? Is this a function? So the question here is, we've got two different inputs resulting in a single output, but that's still okay because the Burger King sandwich and the McDonald's McChicken sandwich, they're different inputs resulting in the same output. That's fine. You just couldn't have the Burger King sandwich going to two different outputs. So this is a function. Yes, it is a function. Problem 19, yours to try. Alright, and lastly, I think you're getting the idea by now. This is not a function because of the 0.71. It's resulting in two different outputs, which is not allowed. Alright, so let's take a look at these. Are these functions? Let's look at the inputs. Are there any repeaters? Here we go. The 2 and the 2. 2 results in 3. 2 results in -1. Not allowed. Alright, so this first one is not a function. Let's take a look at the second one. -2, 4, 3, 2. Any repeats? No, there's not. So this is a function. Yes, here. And lastly, are there any repeats here? Yep, 2 and 2. So this bottom one is a no. So we would have had no, yes, and no. The no's because of these 2's resulting in two different outputs. Alright, let's go ahead and try one more. Determine if the equation y equals -1/2 x minus 3 defines y as a function of x. Alright, so the question is, if you plug a number in for x, will you get a unique answer for y? And the answer here is absolutely, because if you plug in a number for x, let's say 0 minus 3, we're only going to be able to do one thing to that 0. In this case, we're going to multiply it by the half and minus 3, so we'll end up with a -3. There's only one specific outcome that occurs for each input. Alright, so this would be a yes, it is a function. Try 33. Alright, how about this one? X equals, and it's blocked here, but you can see it, 2y squared plus 1. Alright, so if we plug in, let's go with 0 again. 0 equals 2y squared plus 1. So now we've got, actually, you know what? Let me use a better number than 0 for this example. Let me use 2, because now we're going to minus 1. And so now we'll have 1 equals 2y squared. And so we'll have a half equals y squared. And what happens when we square root? We get 2 answers. So we'll have plus or minus square root of 1/2 equals y. That's 2 different things. We plugged in 1x, we plugged in 2. We got 2 different outputs for the y. So that would not be a function. All right, try problem 33. All right, so what happens if we're trying to find the value of a function? So every input has one specific output. And so the way we're going to write this, and you can see it with the function machine, we're going to plug in x. Some stuff's going to happen to it. And we're going to call that stuff f. We don't know exactly what that is, but some things are going to happen to our x. All sorts of stuff happens. And boom, we get a y spit out. All right? So instead of saying y equals something x, maybe 1/2 x plus 3, right? We're going to say f of x equals 1/2 x plus 3. This being the things you need to do to x to get a y value. Now this is also nice because we can say, okay, what happens, what's the y value if we put 3 in? And so we can keep track of what the x is as we go through and spit out a y value. In this case, it would be 4.5. So if you put a 3 in, you get a 4.5 out. All right? So it'll be written like this: f of p equals p squared. All right? The independent variable is p, and q would be the dependent variable, your output. All right? So f of 3 or f at 3 is 9. All right? The domain is all the x's, all the inputs. In this case, the p's, and the range would be all the values you could get, all the y values or the q's. All right, so let's try a few things. What do we get if we plug in various values to 3x squared plus 2x? All right, so the first one, fairly straightforward. We'll walk through these. It's going to be -3, and we'll plug in a 3 wherever we see an x. So we'll get -3 times 9. Oops, sorry, I forgot to plug in my 3. Plus 6, so that's -27 plus 6, or -21. B gets a little trickier. B, f of x, -3x squared plus 2x. This f of x is saying, whenever you see the x, just leave it alone. Leave it as x, all right, whatever you had originally. Plus f of 3, which we already know is -21, so -21. And that'd be your answer there. How about C? 3f of x is the same thing as 3 parentheses the original problem, -3x squared plus 2x. And so we'll have -9x squared. Just distribute that 3 plus 6x. How about D? All right, so f of -x. Everywhere you see an x, it needs to be a -x. So this will be -3x squared, because -x times -x, back to a positive, but now -2x. All right, we're working our way through these from easy to some slightly harder ones. How about E? F of x. So this is going to be negative out front of the -3. Come back. Oh, freaked out on me. Come back. Well, let me pause this for a second. Fix this. All right, we're back in business. Sorry about that. So we had a negative in front of everything. -3x squared plus 2x. So this will be 3x squared minus 2x. F. What happens if we put a 3x wherever we see an x? So this is -3x squared plus 3x. So we've got -3 times 9x squared plus 6x, which will be -27x squared plus 6x. All right, last two, G and H. So g is f of x plus 3. Okay, everywhere we see an x, we need to have an x plus 3. So x plus 3 squared plus 2x plus 3. We need to FOIL this first. Negative 3, x plus 3 times x plus 3 is x squared plus 6x plus 9. We'll distribute this 2x plus 6. So negative 3x squared minus 18x. Minus 27 plus 2x plus 6. Let's clean it up. Negative 3x squared. And we'll put these two together, minus 16x. And we'll put these two together, minus 21. All right. And last one here, this should look somewhat familiar. This is the difference quotient. So let's put it all together. F of x plus h. So this is negative 3 x plus h squared plus 2 x plus h minus, so let's get some brackets here so we can keep the whole thing together, minus negative 3x squared plus 2x, and this will all be over an h. So let's clean this up. Negative 3x squared plus 2xh plus h squared plus 2x plus 2h plus 3x squared minus 6x. This whole thing is all over h. And let's clean this up. Negative 3x squared plus 3x squared will go away. This is going to be negative 6xh. And then we'll have minus 3h squared. And we'll have a plus 2x. Oh, sorry, this is a 2x. Got carried away there. So this and this should cancel out, sorry. And then plus 2h. And all over h. And notice how every single term here has an h in it. We're going to factor that out front. H, negative 6x, minus 3h, plus 2, all over h. Your h's cancel. And we've got a negative 6x, minus 3h, plus 2. Okay, that's a big one. We're going to spend some time going over that one again in class. All right, if you had a hard time following that one through, make sure to ask about it again in class when we talk about it. But for now, let's try 39 and 73. Okay, let's find values of a function on a calculator. This is the easy one. We're going to go to our calculator, plug in these three functions into our y equals. So the first one is x squared. The second one is 1 over x. And the third one here is the square root of x. And so let's go ahead and go to our table. But before we do that, we'll do table set. And we'll make sure we're on ask here for independent, so that when we go to our table, we can plug in the number we want, 1.234. And we've got 1.5228 for the first value. We have 0.81 for the second value. And we have 1.1109 for the third value. Okay, so implicit form of a function is when we have the x and the y on one side. Explicit form is when we have the y on one side all by itself, so that we can write it as f of x. Just a little vocab for you there. And so these are some important facts here. Kind of a summary of what we've already done. For each x in the domain of f, there's exactly one image f of x, right? Exactly one value. F is the symbol that we use to denote the function, and it's going to stand for y. And if y is the f of x, which it will be for our purposes, it's going to be the independent variable. Okay? So x is the independent variable, and y is the dependent variable. Okay, last objective, not objection. Find the domain of a function defined by the equation. Okay, remember there's two problems that can occur. We can't have 0 in the denominator. So our denominator here, x squared minus 2x minus 3, cannot equal 0. We need to factor x minus 3, x plus 1 cannot equal 0. So x cannot equal 3 or negative 1. In this one, the domain would be all real. because there are no denominators and there's no square roots like in the last one. So remember, in a square root, 3 minus 2x has to be greater than or equal to 0. So 3 has to be greater than or equal to 2x, and so 3/2 has to be greater than x, and we like to write it this way: x is less than or equal to 3/2. All right, try problem 51. And here's a quick summary of everything going on. Oh, I apologize. We do have, I think, just one more. Let's see here. Oh, I lied to you. There's another objective. I apologize. Let's finish this up. Here we go. A rectangular garden has a perimeter of 100 feet. So perimeter equals 100, and that's equal to 2 length plus width. And let's express the area as a function of the width. All right, so we know here that if we get length times width, we'll get the area. But we don't want to use L anymore. When it says in terms of W, we only want to have W as the only variable we see on this side of the equation. So up here, we're going to get L all by itself and W on the other side. So let's rewrite this. 100 equals 2 L plus W. So 50 equals L plus W. And so 50 minus W equals L. Let's substitute that in. So the area equals 50 minus W times W. And we have an equation, a function for area in terms of W. So W is the only variable we see. 87 is yours to try. Okay, last objective. This time I promise it's the last one. Find the sum, difference, product, or quotient of two functions. And this is straightforward. If we're going to say f plus g, so one function, and then g could be another function, we would just do them independently and add them together. Same goes for subtraction, for multiplication, and for division. Now when you divide, we have to worry about the domain because you can't have 0 in the denominator. Okay, so 2x squared plus 3 is f, and 4x cubed plus 1 is g. If we added them together, it would be 2x squared plus 3 is f, plus 4x cubed plus 1 is your g. Put them all together, and we've got 4x cubed plus 2x squared plus 4. What if we subtracted them? Same exact thing, but this time we're subtracting. So now we've got negative 4x cubed plus 2x squared and plus 2, 3 minus 1. Let's multiply them together. So we'll have to do a little foiling here. 2x squared plus 3, 4x cubed plus 1. And so first will be 8x to the 5th, and outside will be plus 2x squared. Inside will be plus 12x cubed, and then plus 3. And we would want to rearrange this so they're in the right order. But that's how we would multiply them. And let's divide to finish. 2x squared plus 3 over 4x cubed plus 1. No factoring, so we're going to be done there. We just have to figure out the domain. So we're going to say 4x cubed plus 1 cannot equal 0. So 4x cubed cannot equal negative 1. X cubed cannot equal negative 1/4. And so x cannot equal the cube root of negative 1/4, which is allowed because it's a cube root, not a square root. So we would have the function, and we would also have the domain. All right, 61 for you to try, and we're all done there. Okay, any questions? Make sure you ask them in class. Good luck.